right, I'm going to go ahead and go through some relearning of our factoring. So factoring had a couple of different sections. So the first thing we're going to talk about is how to take out or factor out the GCF, the greatest common factor. So a factor is something that multiplies to give you an answer. So the first thing we're going to do is we're going to find the GCF of the coefficients, the numbers. And what this means is, what is the biggest number I can divide all of the numbers by? After we do that, we're going to go ahead and determine if all terms have a common variable. If they do, we're going to take the variable with the smallest exponent. So you want to take out the smallest amount that all of them have or the biggest amount they all have in common, which is the smallest shared variable. Okay, so we're going to combine number 1 and 2 together to get the greatest common factor, and then we're going to divide that out from each term in the polynomial. Your answer is the greatest common factor times what is left when you divide it out. So we're going to go ahead and work 4 examples on taking out the greatest common factor. So example A here, I have 3x squared minus 15x plus 60. You want your first term to be positive. So for the first 3, my first term is positive, so my GCF is positive. So I'm going to look at the numbers first. So I have a 3, a 15, and a 60. The biggest number that I can divide those 3 by is 3. And then I'm going to look at the x's. The last term does not have an x, so there's no shared variable. So my GCF is only 3. So I'm going to go ahead and divide all of these by 3, and what's left when I do that will be in the parentheses. So 3x squared divided by 3 is x squared, or 1x squared. Negative 15x divided by 3 is negative 5x. And then 60 divided by 3 is positive 20. That would be my final answer. I took out the GCF of 3, and I'm left with what's in the parentheses. So looking at question B here, my numbers are 4 and 8. So the biggest number that I can divide 4 and 8 by is 4. Okay, and then they all have an x in common, and the smallest x is just the 1 in the 8x. So I'm going to take out 4x. That's my GCF. So I'm going to go ahead and divide both terms by 4x. So 4x squared divided by 4x is just an x. 8x divided by 4x, is a positive 2. 8 divided by 4 is 2. The x and x cancel. So my answer would be 4x times x plus 2. Looking at letter C here, I see that there are A's and B's in my answer. We do the same thing. The biggest number that I can divide 6 and 9 by is 3. When I look at my A's, they both have A, and the smallest amount is the 1A. And then they both have a B, and the smallest amount is the 1B. So my GCF is 3AB. So I'm going to go ahead and divide both terms by 3AB. So 6 divided by 3 is 2. I had a squared, but I'm taking away an a, so I only have 1a. And then I had a b, but I took it away, so it's no b's. On to the next one. 9 divided by 3 is a positive 3. My a's went away, and I had 1b left. So this would be the final answer. Looking at letter D, this one has a negative to start our term, which means we want our GCF to be negative. We always want to try to keep that first term positive, and so by removing a negative, it will become positive. The process of finding the GCF is the same. So the number that I can divide 3, 9, and 6 by is 3. And then they only have one x in common, so my GCF is negative 3x. So that's what I'm going to divide out. So negative 3 divided by negative 3 is a positive 1. X squared divided by x is, x to the third divided by x is x squared. A negative 9 divided by a negative 3 is a positive 3. X squared divided by x is x. Positive 6 divided by negative 3 is a negative 2, and our x's cancel, so that's what we would be left with. All right. Looking forward, I combined two sections because the process is the same for them. We're going to talk about factoring trinomials where a is 1 and a is greater than 1. So to do this, we're going to look at the standard form of a triangle, and that's a squared plus ax squared, plus bx plus c. So we can use the standard form and the x in box method to help us factor. So in the x, we're going to go ahead on top. We're going to multiply. We're going to try to find two numbers that multiply to our a times our c number. And then on the bottom of our x, we want to add to our b number. Okay, and so what we're going to do is we're going to kind of do a little bit of a math riddle or something where you're going to try to find two numbers that work in that x. And then from this x, we're going to transfer it over to a box. So inside this x, you're going to get a number here and a number here, and they're both going to have x's in it. So those two things are going to go in these two boxes. From there, you're going to steal your first term and your last term and put them in the box. So the last term's going to go in the last box, and the first term's going to go in the first box. So we're going to have ax squared, and then down here we're going to have our c term. From there, you're going to factor out greatest common factors, or find, you don't actually have to factor it out, but find the greatest common factor like we did above. So I'm going to go ahead and walk through a couple of examples here. So looking at the first one, I'm going to go ahead and draw my x and my box. That helps me kind of keep the problem contained. So here, a is the number that's before x squared, which is 1. B is the number that's before x, which is negative 2. And c is the constant at the end, which is negative 15. So on the box, on the x, we're going to multiply to a times c. So 1 times negative 15 is negative 15. And then we're going to add to our b, which here is negative 2. So now comes the math riddle. I want to find two numbers that multiply to negative 15 and they add to negative 2. So I need to think about what numbers can I multiply to negative 15. So the answer is negative 1 and 15, negative 3 and 5, positive 1 and negative 15, and 3 and negative 5. So I have 4 options to choose from, and we want the combo that adds to a negative 2. So that tells me that I'm going to use a 3x and a negative 5x. So inside the box, those numbers are going to go 3x and negative 5x. The first square is going to be from our first term, which here is x squared. The last term is going to go into our last box. And now we get to find greatest common factor, which is similar to what we did above. So here I have two terms, 1x squared and 3x. So the number that I can divide 1 and 3 by is just 1. And they both have an x in common, so this would just be an x. Down here, once again, we want our first term to be positive. If it's negative, then our GCF is negative. So I can divide 5 and 15 by 5. They don't have the same variables, so that isn't part of the GCF. So the GCF is just negative 5. So now I'm going to go ahead and go up and down. So here the greatest common factor of 1 and negative 5 is just 1 again. They both share an x, so my GCF is x. Here the GCF between 3 and 15 is 3. My top term is positive, so my GCF is positive, and then they don't have an x in common. So these make up my two answers for my GCF. I would have x minus 5 and x plus 3. This would be my factored answer. So I'm going to go ahead, show the process again on problem B. So problem B here, my a is still 1. It's before x squared. My b is negative 11. And my c is positive 10. So I'm going to go ahead, make my x and my box. So on the x, the top number, we're going to multiply our a times our c. So 1 times 10 is 10. And then we're going to add to negative 11. So I want to multiply to a positive 10 and add to a negative 11. So this is going to tell me that I'm going to have two negatives. Okay, so to multiply to 10, we would have 1 and 10, 2 and 5, but we could also have negative 1 and negative 10, negative 2 and negative 5. So the combo of those that adds to negative 11 is this one right here. So I'm going to have a negative 1x and a negative 10x. So now inside the boxes, the first box is your first term, so x squared. The last box is your last term, positive 10, and then the other two come from those two on the x, so negative 1x and negative 10x. So now I'm going to go ahead and find my GCFs of each row and column. So this would be an x, this would be a negative 10, this one here would be an x, and this one would be a negative 1. So that would leave me with the answer x minus 10, x minus 1. That would be my factored answer. All right, let's look at letter C. Here my a is still 1. My b is 176. And my c is 10. So I'm going to go ahead, make my x. I want to multiply to my a times my c. So 1 times 10 is 10. And I'm going to go ahead and add to b, which is 176. Sometimes we get problems that you can't find two numbers that make it happen. So here I cannot have two numbers that multiply to 10 and also add to 176. So we say this is not factorable. Okay. Letter D, same process. Our A here is a 7 this time. Our B is the 15, and C is 2. Okay, so on the X, we're going to multiply to A times C. So 7 times 2 is 14. And we're going to add to B, which is 15. Okay, so factors of 14, or what I would multiply to get 14, are 1 and 14, 2 and 7. So the ones that add to positive 15 would be a positive 1 and a positive 14. So now I'm going to go ahead and make the box. So here my first term was 7x squared. Be careful that you're writing the first term of the problem. Okay, the first term of the problem right here says 7x squared. And then the last term is a positive 2. So we would have a positive 1x here and a positive 14x here. So we're going to go ahead, find our greatest common factors. So this would be just an x. This one here would be a 2. Going up and down, we would have a 7x. And then here I would have a 1. So my final answer would be x plus 2, 7x plus 1. Okay, 2 more sections. The first one we're going to talk about is this thing that's called special products. And so we're going to look at using the difference of squares. So if we break down that meaning, the word difference means a subtraction. So this only works on subtraction problems. And squares is any number times itself. Okay, we want a number times itself. And so we kind of have this format of it that a squared minus b squared has to equal a plus b times a minus b. And what we can look at is we can look at breaking down the a squared and the b squared, and we could say, okay, what can I multiply times itself to give me a squared? And the answer is a. And then what can I multiply by itself to give me b squared? And the answer is b. So then I put a in the front, b in the back, and I add and subtract 1. Okay, so let's look at problem A here. Okay, so the first thing you want to check is it a subtraction problem? And the answer is yes. So now I'm going to ask myself, what can I multiply by itself and get x squared? And the answer is x. X times x is x squared. Now I'm going to go ahead and look at that 36. What can I multiply by itself to get 36? And the answer is 6. So in my parentheses, my x will be first, followed by my 6, and I'm going to have 1 plus and 1 minus. That would be my factored form. Okay, looking at letter B, it is a subtraction problem, so we can go ahead and break it up. So I want to figure out what number times itself, or what value times itself gives me 81x squared. So that would be 9x times 9x. And then times itself would be 2. 2 times 2 is 4. So I would get 9x plus 2, 9x minus 2. If you look at letter C, this one is not a subtraction problem, so we would call this one not factorable. We cannot use the difference of squares here because it's not a difference and it's not squares either. Letter D, we can go ahead. This is a subtraction problem, so I'm going to break them up. What value times itself is 9x squared? That would be 3x times 3x. The value times itself to get 25 would be 5 times 5. So I would have 3x plus 5 and 3x minus 5. All right, the last part of this is using more than one method. So to use or to do these problems, the first thing you're going to do is factor out the GCF. So that is similar, or what we did when we did the first section of this review. So right here, my GCF here is just x. So there's no number that, well, number 1 that I could divide, but that doesn't help us. And then we could take out 1x. So when I factor out that x, I have x squared minus 25. What happens on these problems is you can break down what's left after you take the GCF out. Okay, just on the section that says more than one method. So here, this looks similar to the ones that we were just doing where I could break these up. So x times x is x squared. 5 times 5 is 25. So this part in the parentheses, or in the highlight, I'm sorry, is going to be x plus 5 and x minus 5. I still have to bring down that GCF though, because that completes my problem. It's the GCF and then factor what's in the parentheses. So looking at letter B, I can divide all of these numbers by 2. They do not have an x in common, so I'm only going to divide everything by 2. So this would be x squared plus 14x plus 49. From here, this is not a difference of squares, so it wants to wants to have us use the x in the box here to factor this. So my A is 1, my B is 14, and my C is 49. So I want two numbers that multiply to 49 and add to 14. Well, 49 is 7 times 7. So those are going to be 7x. Now, when I go to use the box, make sure you're only doing the highlighted part. That 2 in front is the GCF, and that'll go on our problem at the end. So I have x squared and 49, and then I have 7x and 7x. So we're going to go ahead, factor out or factor the GCF. So here it would be x, here it would be 7, here it would be x, and here it would be 7. So that part of it is x plus 7, x plus 7. So my final answer is 2 times x plus 7 times x plus 7. So we can't forget that our GCF comes down into our answer. All right, and then on the last one, here it looks like all of my numbers again can be divided by 2, but they also have an x in common. So I'm going to go ahead and start by taking out 2x. So here I would have an x squared, then I would have a 3x, and then I would have a 7. And so if I go ahead and look in here, at factoring this, I would want the numbers that multiply to 7 and add to 3. So actually, this one doesn't have two methods. I might have done a typo on it, but this would be your final answer. You cannot factor the inside that's highlighted anymore, and so we just leave it at that.